It's probably not surprising that in general, firms operate with the goal of maximizing profit. Therefore, it's important to understand what profit is, where it comes from, and how it's calculated. In order to analyze profit, we must first look at how to measure revenue and cost. Revenue is simply the number of dollars or other currency that a firm receives for selling its output. Depending on the situation, it may make sense to think in terms of total revenue, or it may be more helpful to break revenue down into average revenue or marginal revenue. Let's examine each of these quantities in turn. If a firm sells all of its output for the same price, then total revenue is simply the selling price times the quantity sold. As you can see here, total revenue, which is oftentimes abbreviated TR, is just price times quantity. So for example, if I sell 12 apples at $2 each, then my total revenue is just the price, which is $2, times the quantity, which is 12, or $24. Notice the total revenue has units of dollars, or whatever currency it is that you're working with. If a firm sells different items, or even the same item, at different prices, then total revenue is calculated by multiplying price times quantity for each item, or each price point, and then adding the amounts together. So we have here, total revenue is just the price of the first item times how many of the first item you sold, plus the price of the second item times the quantity of the second item that you sold, and so on and so forth. Now this isn't for every individual item, it's just for every individual category of items. So for example here, say now we're selling 12 apples at $2 each and 5 oranges at $3 each. Our total revenue is just the price of apples times the quantity of apples, plus the price of oranges times the quantity of oranges, which is just $2 times 12 plus $3 times 5, which gives us $39 of total revenue. Average revenue, simply put, is just total revenue divided by the quantity sold, and it reflects how much money on average a firm gets from selling one item. So we see here, average revenue, which is usually abbreviated AR, is just total revenue divided by quantity. You'll notice that if a firm sells all of its output at one price, then average revenue is just equal to that price. The math here is simple. If average revenue is equal to total revenue divided by quantity, and then total revenue is just price times quantity, well, you'll notice here that the Q's cancel out and you're just left with price. So for example, if I sell 12 apples at $2 each, then the revenue I bring in from each apple is just $2, which is the price. Note that average revenue is going to have units of dollars per item. Marginal revenue reflects how much additional revenue a firm gets from selling one more unit of output. Mathematically, marginal revenue is stated like this. We've got marginal revenue, which is usually abbreviated with MR. And we just say that marginal revenue is just the change in total revenue divided by the change in quantity. Note here that when we're dealing with discrete units of product, we try to look at marginal revenue over small changes in quantity, so this change in quantity is usually equal to 1. One thing that's important to keep in mind is that marginal revenue is defined in relation to a particular level of output. So we would define the marginal revenue of increasing quantity from 9 units to 10 units, or 10 units to 11 units, or something like that. Then marginal revenue is not necessarily constant over all choices of units. The other thing to notice is that despite what it might be convenient to think at first, marginal revenue is not necessarily equal to the item's price, and we can see why here with an example. So say we have the following setup. We can either sell 9 apples at $2 each, or we can sell 10 apples at $1.90 each. Now, these choices make sense because in a lot of cases, in order to be able to sell more output, we're going to have to lower the price. Now, what we'll see in the absence of price discrimination is that we have to sell all units at the same price. So if we lower the price of the 10th unit to $1.90, we have to lower the price of all of the units to $1.90. So we see what happens here. Marginal revenue, again, is just the change in total revenue divided by the change in quantity. The change in total revenue is just final total revenue minus initial total revenue, which is price times quantity for the second option minus price times quantity for the first option. So we have $1.90 times 10 minus $2 times 9. This is all divided by the change in quantity, which is just final quantity minus initial quantity, or 10 minus 9. And what we notice, doing a little bit of arithmetic, is that our marginal revenue from selling this 10th apple is only $1, which is noticeably less than the price of that 10th apple, which is $1.90. In general, when facing a downward sloping demand curve, we're going to see that the marginal revenue is actually less than our price. And the only way that these two quantities can be equal is if we're facing perfectly elastic demand and don't have to lower our price at all in order to sell more output. When calculating marginal revenue, we can actually break the process down into two separate effects, namely the output effect and the price effect. The output effect is simply the extra dollars you take in as a result of selling the extra output. So in this case, since you sold that 10th apple at $1.90, you took in an extra $1.90 from that extra output, and the output effect is $1.90. The other effect is the price effect, and this refers to the lost revenue from all the units that you were already selling before, but you're now selling at a lower price. So in this example, you were already selling 9 apples, and you used to be selling 9 apples at $2 each. Now you're selling those first 9 apples at $1.90 each. So your price effect is negative, and it reflects the fact that you're getting 10 cents less per apple on those first 9 apples. So you can see your price effect is a decrease in revenue on what you were already selling of 90 cents. You'll then notice that the total of the output effect and the price effect is $1.90 minus 90 cents, which is $1, which is equal to the marginal revenue. So in that sense, the marginal revenue is equal to the sum of the output effect and the price effect. And you'll also notice that marginal revenue has the units of dollars. In addition to marginal revenue generally being less than the price of an item, marginal revenue can even be negative. To see this, let's again start with our 9 apples at $2 each. But this time, let's say that we have to lower our price to $1.50 in order to sell a 10th apple. In this case, my marginal revenue, again, is just the change in total revenue divided by the change in quantity. So we have the price at the second option times the quantity at the second option, or $1.50 times 10, minus the price at the first option times the quantity at the first option, or $2 times 9, divided by the change in quantity, or just the second quantity minus the first quantity, 10 minus 9. We'll notice that this is $15 minus $18 divided by, 1, giving us a marginal revenue of negative $3. So we've shown that if you have to lower your price a lot in order to sell more output, it's entirely possible that you could make less revenue by trying to sell more output. Technically speaking, your marginal revenue in this case is negative because your price effect dominates your output effect. In this case, the output effect is $1.50 because you're getting $1.50 from that extra apple that you're selling. Unfortunately, in this case, your price effect is the product of the lowering of the price, or 50 cents, times the apples that you had already been selling. So you're losing 50 cents on each of the first 9 apples when you try to sell that 10th apple, giving you a price effect of 50 cents times 9, or $4.50. So if your price effect is negative $4.50 and your output effect is $1.50, that gives you a negative number for your total, which is marginal revenue. For those of you who are mathematically inclined, it's worth noting that as smaller and smaller changes in quantity are considered, and your changes in quantity become continuous rather than discrete, the marginal revenue calculation approaches the derivative of total revenue with respect to quantity. So you can think for very, very small continuous changes in quantity, marginal revenue is equal to the derivative of total revenue with respect to quantity.